Okay, so in the case of resonating structures, that's when double or triple bonds appear. So, how do you do a Lewis dot structure for a double or a triple bond? So let's do oxygen, for example. So oxygen has 6 electrons around it, and the other oxygen has 6 electrons around it. Each oxygen needs 8. So if I take one from here, and I take one from here, now each oxygen has got 7, but I need 8. So a double bond is when you share 2 pairs of electrons. So I can take this one, put him there, and I can take this one and put it here. So now each oxygen has 8 electrons around it, and we would signify a double bond with 2 lines. Okay? So that's the way you would do a double bond. So the elements that like to double bond are oxygen and carbon, and very rarely sulfur, or as I like to call it, SOx. Okay? Triple bonds, take a look at nitrogen. Nitrogen starts with 5 electrons because it's in group 5A. And the other nitrogen has 5 electrons. And again, you can put the dots wherever you want when you're dealing with compounds. I have to get 8 around each nitrogen. Well, the way I could do this is I could form a bond here, and then I've got 2, 4, 6 around each nitrogen, but I need 8 electrons around each. So just like with the oxygen, I'm going to pair them up. Now I've got 7 around each. And one way that you know you're doing Lewis dot structures right is that you should never have an electron by itself when you're done. They're always paired up. So I could take this electron, move him there, and take this electron and move it here. And so then they each have 8. Now to make it look a little bit prettier, I'm going to move these two. I'm going to move these 2 electrons. I'm going to move those 2 electrons and just put them on that side, just so it's clear. And I'm going to do the same thing over here, just to make it look nice and pretty. All right? So each has 8 electrons around it. So now let's take the case of carbonate. Okay? Carbonate's a good example. So carbon is in the center, and I got my 3 oxygens around it. Okay? Put the oxygen up there. And each oxygen has 6 electrons. And the carbon starts off with 4. Okay? Now, if I go back to my appendix F, I will see that in group 4A, I'm going to need 8 electrons. So the carbon family, I'm going to have to get 8 around it. Oxygen must get 8 around it. Okay, so I got to get 8 around the carbon, 8 around the oxygen. Because I have a -2 charge, I get a bonus 2 electrons, which I'm going to indicate by my stars. So I get 2 bonus. I always kind of like these because they're kind of like a puzzle trying to solve. So now how am I going to get 8 electrons around each? Well, I'm going to have to form a double bond. And what I'm going to do is I'm going to take these 2 electrons and I'm going to put it right there. And the reason why I do that is because now I have 8 around that oxygen, 8 around that oxygen, 8 around that oxygen, and I put in a double bond to get 8 around the carbon. If I were to draw out the line bond structure, it would look like this. Okay? Because there's a -2 charge, I have to put brackets around. So that would be the Lewis dot structure for carbonate. Okay? So I had to put in a double bond on that carbon. All right? Now, does the double bond have to be over here? Couldn't the double bond be up here? Or couldn't the double bond be over there? So if it appears that the double bond can be in more than one spot, we say the double bond resonates. And so what you have is really 3 possibilities. You could have the double bond there. You could have the double bond here. You could have the double bond here. So that gets to be a real pain in the butt having to draw all possibilities. So instead of drawing these 3 structures, you can indicate resonance by introducing a dashed line. That dashed line means that the double bond is resonating. Okay? Now, I'll make a video that explains what is actually happening with a resonating double bond. Some chemistry teachers get this wrong in that the double bond is not actually moving from place to place. Okay? The double bond is not moving from place to place. The double bond is actually in all 3 places at once. So with a resonating bond, that double bond is actually in all 3 places at once. And I'll make a separate video, and I'll put that at the end, and I'll make that optional as to explaining how is it a double bond is in 3 places at once. But let's do one more example. Let's do phosphate. All right. So phosphorus goes in the middle. I've got my 4 oxygens around it. Each oxygen has 6 electrons because it's in group 6A. The phosphorus is in group 5A. I can leave that there. So it starts with 5. And I've got a -3 charge. So that means I get 3 bonus electrons. And I'm going to put them there. And already I can see that I'm going to get 8, 8, 8, 8, 8 with a -3 charge. And I believe everybody is happy. So I go look at my appendix F, and sure enough, there's good old phosphorus, and phosphorus follows the rule of 8. But wait, it can also follow the rule of 10. So that means I have to go back and check to see if it follows the rule of 10 as well. It's in the middle of my molecule, so there's a good chance that it will. The line bond structure for this is that. Okay, so let's see now if we can redo this Lewis dot structure, but this time following the rule of 12. So each oxygen starts with 6. And the phosphorus starts with 5. I get 3 bonus electrons, which is, by the way, phosphorus forms a -3 because it makes everything work out nicely. Now, is it possible to get 10 around the phosphorus and keep everybody happy? It is. We can take those 2 electrons and put them right there. I'm going to still have 8 around my oxygen, but now I'm going to have 10 around my phosphorus by introducing a double bond right there. Put my brackets. So this is an example where it can follow the rule of 10 or it can follow the rule of 8. Okay? So both examples have to be put. When does this usually occur? It usually occurs when you see oxygen. So you don't typically see more than one choice unless there's oxygen or carbon. Okay? All right, so because my double bond can be in more than one spot, right, the double bond could be here, it could be here, it could be here, it could be here. So that means it resonates, and so I'm going to draw in dashed lines to indicate that my double bond is resonating. Okay, so whenever you see oxygen or carbon, look for resonating structures, but definitely when you see oxygen there. Okay, I did forget one thing about the triple bonds. The only elements that can triple bond are nitrogen and carbon, and in a very, very rare circumstance, oxygen. So my mnemonic, or the way I remember, is the elements that double bond are SOx, and the elements that triple bond are NOx. Okay? So you got to have at least one of those elements to form a double or a triple bond. So in this example down here, I have oxygen present, so I can form a double bond. So you got to have at least an oxygen, a carbon, or a sulfur in order to form a double bond. Okay? And you have to have at least a nitrogen or an oxygen or a carbon to form a triple bond.